So now we're going to move into solving trig equations when we have something other than just one x. And in this case, we have 2x. And I'm going to solve this by using substitution. So here we go. So the first thing I'm going to do is I'm going to introduce a new variable. And I think I'll use z. Let z equal 2x. So in order to do this problem, we are going to have to depend on our knowledge of general solutions. So we're going to introduce this new variable, cosine z equals -1. Now when we do that, it's easy to solve for z. So think about the unit circle and cosine equals -1. Cosine equals -1 only over here at pi. So z equals pi plus 2 pi times n being representing a complete revolution. Now, this is z. We have solved for z. Now we're going to put z back in. Remember, z equals 2x. So since z equals 2x, we're going to plug it in right here and solve for x, because that's what we're really after. So 2x equals pi plus 2 pi times n. From here, remember we're solving for x, so we're going to divide by 2. Divide all the way across the equation by 2. So x equals pi over 2. Cancel those 2's, plus pi times n. This is the general solution for x. Now, we want to now find the specific solutions. And remember, we want our specific solutions to live within this slice of the domain, from 0 to 2 pi. So we have to come up with some test values. So first of all, let n equal 0. So if we don't do any revolutions whatsoever, then x equals pi over 2 plus pi times 0, which of course is 0. That is pi over 2. If we let n equal 1, then x equals pi over 2 plus pi times 1, which of course is pi. So 1/2 plus 1 whole is 3/2 pi. And then finally, if we let n equal 2, x equals pi over 2 plus pi times 2, which of course is 2 pi, and that's 2.5 pi, which is now too big because 2.5 pi is bigger than 2 pi. So using substitution, we're able to find our specific solutions. Our specific solutions, x equals the solution set, pi over 2 times 3 pi over 2, or comma 3 pi over 2. So let's make a generalization here. If we look back at our argument of our trig function here, it's 2 times x. So because this is 2 times x, we just doubled the number of solutions. We doubled the number of solutions. Normally we would have only had 1, but we just doubled them and got 2. So 2x doubles the number of our solutions. So we had 1 general solution and 2 specific solutions. So if 2x doubles the number of solutions, then 3x should triple the number of solutions. So let's check it out on this problem. Sine 3x equals √2 over 2. So once again, introduce a variable. This time we'll use t. Let t equal 3x. So we're going to substitute in t for 3x. Sine t equals √2 over 2. Now we're familiar with √2 over 2. First of all, where is the sign positive? The sign is positive in quadrant 1 and quadrant 2. And of course, the sign is equal to root 2 over 2 at pi over 4 and 3 pi over 4. Both of these rotations have 45-degree reference angles. So we're going to have two general solutions. So start here. So t equals pi over 4 plus 2 pi times n. T also equals, I think I'll write it right here, t also equals 3 pi over 4 plus 2 pi times n. But once again, remember, we're not solving for t. We want to know x. So we're going to take our t value and we're going to plug it back in. T is equal to 3x. So 3x equals pi over 4 plus 2 pi times n. 3x also equals 3 pi over 4 plus 2 pi times n. So now we are going to solve for x. We're going to solve for x by dividing everything by 3. So we're dividing each term in each of our general solutions by 3 to get our general solutions for x, not t. So 3's cancel, x equals, and then pi over 12 plus 2/3 pi times n. Remember, n represents an integer. 3's cancel, x equals, 3's cancel, pi over 4 plus 2/3 pi n. So here are our two general solutions. And whenever we have to start with some sort of substitution value, we're always going to go to those general solutions first. So using those general solutions, we're now going to set up a table, and we're going to first let n equal 0, and we're going to plug in zeros in both of these spots. And we'll just keep our line right there. X equals pi over 12 plus 2/3 pi times n. If n is 0, then that's pi over 12 plus 0, which is pi over 12. Again, on the other side, remember we canceled those 3's. That's why they're not there. So we've got pi over 4 plus 2/3 pi times 0, which again is 0. So that gives us pi over 4. So these are our first two solutions. Remember, we're expecting the number of our solutions to triple. So if we started out with two general solutions, that means we're going to have 2 times 3 to get the number of specific solutions. So we're anticipating 6 specific solutions here while we're going through our table. So let's put in n equals 1. When we plug in n equals 1 into those general solutions, x equals pi over 12 plus 2/3 pi times 1. So that's 2/3 pi times 1 is 2/3 pi. So we need a common denominator, of course, to add these fractions together. Times 4 times 4. So that is pi over 12 plus 8 pi over 12. That is 9 pi over 12, which of course we can reduce by 3's, is the same as 3 pi over 4. Next, plugging in n equals 1 into the second general equation. So x equals pi over 4 plus 2 pi over 3 times 1, which is 2 pi over 3. So we need another common denominator, which of course is going to be 12 times 3 times 3 times 4 times 4. So we have 3 pi over 12 plus 8 pi over 12. that is 11 pi over 12. So first specific solution, second specific solution, third specific solution, fourth specific solution. And remember, our solutions have to live between 0 and 2 pi. So we're not even close yet because this isn't even equal to 1. So we keep going. Now let's plug in n equals 2. N equals 2. Remember, we're plugging it in here and there in order to generate specific solutions. So x equals pi over 12 plus 2/3 pi times 2. And of course, 2/3 pi times 2 is 4/3 pi. So pi over 12 plus 4/3 pi. So once again, we need a common denominator times 4 times 4. So we end up with pi over 12 plus 16 pi over 12, which is 17 pi over 12. So 1, 2, 3, 4, 5. Now we're up to 5. We are anticipating one more specific solution when n equals 2, plugging it in into the second general equation. X equals pi over 4 plus 2 pi over 3 times 2. Once again, that is 4 pi over 3. So we have pi over 4 plus 4 pi over 3. Once again, we need a common denominator of 12 times 3 times 3. Whoop, on the top. Times 4 times 4. So we've got 3 pi over 12 plus 16 pi over 12. That is 19 pi over 12. There we go. So 1, 2, 3, 4, 5, 6. Now, we can come up with a pattern of what's happening here. So look at how it's increasing. So think about it. 1/4, which is really 3/12. So we went 3/12, 11/12, 19/12. So we're going up by 8/12 pi. If we go up by 8/12 here, we're going to be at 27 pi over 12, which will be bigger than 2 pi. Same thing here. If we go up another 8/12 here, we'll be at 25 pi over 12, which is bigger than 2 pi. So we have found our 6 specific solutions. So let's list them. Let's list them right down here on the bottom of the piece of paper that I've got for us. So finally, in conclusion, specifically, x equals pi over 12, pi over 4, 3 pi over 4, 11 pi over 12, 17 pi over 12, and then finally 19 pi over 12. 1, 2, 3, 4, 5, 6. 6 specific solutions for this particular equation. Let's go back all the way to the top just so you can see it once more. We had sine 3x equals root 2 over 2. We were anticipating that we would triple our number of solutions when we have sine of 3x.